lesson, we're going to look at relative frequency, fairness, and expected frequency. The probability of an event occurring can be estimated from statistical data derived from experiments or observations. And relative frequency is an estimate of the actual probability of an event occurring. Relative frequency as a formula is the frequency of something happening over the total number of trials. So let's take something that we know about, dice. The probability of getting a 6 on a fair dice. You've seen dice that maybe not be 6-sided and they have all sorts of funny sides on them, hexagonal shapes and all sorts of things, wouldn't be fair. So the probability of a dice, when it's fair, the probability of a 6, you already know, is 1/6. So what about if we roll the dice 120 times? The expected frequency how many times would we expect to get a 6, is the total number of trials multiplied by the relative frequency. So we would expect 20 6s. Now this is an estimate. That's why we said it was an estimate earlier, because when we roll a dice 120 times, sometimes we may get 25 6s, sometimes we may get 15 6s, but the expected frequency will be 20. So when I read this question, pause the video and try and answer the questions. A coin is flipped 500 times. The results are 230 tails, heads, and 270 tails. Find the relative frequency for heads and tails. Is the coin fair? And what would be the expected frequency? Okay, so the relative frequency for heads, 230 over 500. We could write this as a decimal. It will be 460 out of 1,000, so this is going to be 0.46 for tails. 270 over 500, which is 0.54. What do these two numbers add up to? You can see they add up to 1. Is the coin fair? Well, in my opinion, this coin would be fair. As the relative frequency is very close to the expected frequency. And that's the last part of this question. What is the expected frequency? Well, 250 over 500 will be 0.5. So the expected frequency for each will be 0.5. 0.54 is pretty close to that. 0.46 is pretty close to that. And the more of these trials you run, and we'll look at this in class, the more of these trials that you run, it will get very, very close to the expected frequency as the number of trials increases, which is an important piece of information to know. Tree diagrams in probability are a nice way to look at probabilities. So if we flip a fair coin 3 times, what are our options? So here's my coin. I can get a head, or I can get a tail. So now I'm flipping my coin again. The second time, I can also get a head or a tail if I've gotten the head the first time. And I can also get a head and a tail if I get a tail the first time. And similarly, if I'm up here at this head, I can get a head the 3rd time in a row, or it could be head, head, tail. At this tail, I could get a head again and a tail again. And from this head, I could get a head again or a tail again. And from this tail, I could get a head again, or I could get a 3rd tail in a row. So let's write out all these potential probabilities. You can see here, going in this direction, I have head, head, head. There's only one of them. I have head, head, tail. I have head, tail, head. I have head, tail, tail. That's the first 4 above that line. Now I have tail, head, head. I have tail, head, tail. I have tail, tail, head. and I have tail, tail, tail. So these are my 8 different probabilities. The odds of them all is the same. 1 over 2 by 1 over 2 by 1 over 2 is 1 over 8. And you can see there's 1, 3 heads. Now, there's a pattern here. There's also one of these guys. And there's 6 left. Now, look at this one. This one has 2 heads and a tail. This one has 2 heads and a tail. And this one has 2 heads and a tail. So there's 3 of them. So 2 heads, 1 tail. So if we wanted a probability of 2 heads and 1 tail in any order, it will be 3 over 8. And if we want the probability of 2 tails and 1 head, it's also 3 over 8. And let's just look at those. 2 tails and 1 head. There's 1 of them. There's 2 of them. And there's 3 of them. So this is in any order. So learn these probabilities off for 2 coins. It's never going to change. And these questions come up quite regularly.
Irish Water says domestic metering data shows households are using an additional.
And the touchscreen thing is amazing. So you're on, you don't have that on a laptop, right? You probably could have it on a laptop. It's amazing.
Washing your hands for 20 seconds can use around 1 litre of water.
See her surname.
Increased hand washing accounts for some of the 20% increase in domestic water usage. But not all.
The influencer.
Says domestic metering data shows that an additional 24 litres of water is being used per person per day. There has been a noticeable increase in usage during fine weather, which Irish Water says shows that people are using it for non-essential purposes like paddling pools and power hosing.
So they're saying here it was 81849 from until the 5th of March.
Yeah, that's pretty good.
So it's 1649 now. It's a fucking fair wage for it.
No, that's, you get what you pay for.
This is your one here, isn't it? This is your Microsoft Surface Book, isn't it?
I have a 5 Microsoft Surface Pro 7.
Can I check what that is?
Yeah.
Microsoft what?
Surface Pro 7.
And leaking taps should be fixed.
Over the past 2.5 months or so, we've only had around about 1 month's average rainfall.
And you can see the probabilities add up to 1. Now let's go and test yourself on a few questions. Okay, read this question, pause the video, write your answers down, and hopefully you get all 3 correct. So a fair six-sided dice is rolled. Find the probability of the dice landing on an even number. Well, what are my possibilities here? 2, 4, and 6 are the 3 even numbers. So total possibilities, everything's going to be out of 6 here. 3 out of 6. A prime number. Well, what are my prime numbers between 2 and 6? 2, 3, and 5. Not 1, not 4, and not 6. So my answer is 3 over 6. And a number greater than 4, well, it has to be a 5 or 6. So 2 over 6. Now, you could simplify these if you wanted. 3 over 6 is equal to a half, but you don't need to in probability. There's no extra marks, as I said previously, for simplifying them. And I like to always see the total possible outcomes on the bottom of these fractions. Try the next one now. So read this question and then pause the video and see can you get the correct answers. Last season, Mo Salah scored 30 times in 50 matches. Find the relative frequency of Mo Salah scoring. And if he scores 5 times in the first 12 games of the next season, has his scoring rate improved? Okay. 30 out of 50, part A. Now, we could write this as a decimal. It might make it a little bit simpler. 60 out of 100, so it's 0.6. So the maths involved, here's a heavily worded probability question, but the maths involved is really short. Part B, it's an opinion, but it's based on the maths behind your opinion. So has the scoring rate improved? 5 over 12? We can see 5 over 12 is less than half. Because you can see that it's less than half, you could say less than half, or you could type it into your calculator and change to the decimal. Comes out approximately 0.416, so let's say 0.42. So you could say here is scoring rate has decreased. You could also add, but Liverpool are still going to win the championship. but it's not necessary in this case. A fair 6-sided dice is rolled 500 times. Calculate the number of times a 6 is rolled. You can see from the table below we're given all the numbers apart from a 6. And then write the relative frequency for each outcome correct to 1 decimal place. So really simple. The first question is just 500. Take away all of these numbers added together. 71 plus 83 plus 69 plus 74 plus 107. So that's 500 minus 404, which is equal to 96. Put your 96 in, and now the relative frequency of each to correct to 1 decimal place. So the number 1 is 71 over 500. The number 2 is 83 over 500. The number 3, 69 over 500. The number 4, 74 over 500. The number 5 is 107 over 500. And the number 6 is 96 over 500, and correct to 1 decimal place. So just type these into your calculator, or if you want to do it manually, 71 out of 500 will be 142 out of 1000, which is 0.142. So correct to 1 decimal place, 0.1. 83 over 500 is 0. Now that will be 166 out of 1000, 166. So 0.2. 69 will be 138 out of 1000, 0.138. 0.1. 74 out of 500 is 148 out of 1000, 0.148. So again, 0.1. 107 out of 500 is 214 out of 1000, 0.214 or 0.2. And 96 out of 500 will be 192 out of 1000, 0.192, which will be 0.2. Now, is rounding to 1 decimal place a good idea in this question, would you say? And you might think, no, it doesn't give a real accurate representation. And these are the types of questions that you can get asked. You may be asked, what would be a better representation for the probabilities? And I think in this case, probably 3 decimal places gives you the best representation because it's completely accurate. 2 decimal places will be rounded off again, and you want probabilities. You want all these numbers adding up to 1. And if you add all of these numbers up, they'll add up to 1. But look at the 0. The 1 decimal places. We have 0.1, 0.2, 0.1. So a 1, a 2, a 1, a 1, a 2, a 2. So we have 3 2s and 3 1s, which add up to 0.9. So you can see here they don't add up to 1. So 3 decimal places will be a better representation in this case of the probabilities or the relative frequencies of each of these rows. Another question that could be posed with this set of data is which number on the dice is closest to the expected frequency. So what's my expected frequency here? One over 6. So 1 over 6 as a decimal is 0.16 repeated. So you can see here the number 2 matches off with my expected frequency. So the answer would be number 2.